All right, welcome back. We're here at section 7.4, and today we're going to learn some properties of logarithms. So these are in your notes. Make sure to have those available as we're going through those. Don't be afraid to put some examples down as you practice, just to have those available. So first thing we're going to talk about is that, remember, if you're going to multiply powers with the same base, you're going to add the exponents. Well, the same thing holds true with logarithms. If you have a log, if you have the same base and you're adding them, you can simply write it as a singular log and multiply the m and the m together. Okay, and that simplifies things. We always want to try to get it as a singular log if at all possible. So here we go. Let's see what happens when we do this. So we do have the same base. So what we can do is write it as a singular log. We can just say log base 6. Multiply the 4 times the 9, that's 36. Well, then we think 6 to what power equals 36? Well, that's just got to be 2. Okay, so when it says express as a singular log, that's what we're doing right there. And then simplify, that's what we got for our final answer. All right, so make sure we do those. All right, now the next part here, oh boy, tricky one here. All right, we have the same base. And so what we're going to do is, once again, we're just going to write it as a singular log. We're going to say log base 5. We're going to take 625 times 25, which is, of course, 15,625. All right, so what we want to know is this. Now, this might be a good time, as we kind of talked about before. We had that log base on our calculator. Let's just kind of go back through that again. We'll kind of close that. Let's go over here and let's actually do that log base. We have that entered in. It's 5. And again, let's see that number. Let's see, what did we have? 15,625. Okay. 15,625. Go ahead and hit enter. Look at that, and we get it solved for 6. So again, that log base is kind of a nice thing to have on the calculator here as we kind of go through those. And so again, thing from last time. Let's see, let's clear that up. All right, we'll get back over here. All right, so there it is. That's that one. All right, how about this one? This time we have the base of 1/3. So we're just going to say log of 1/3. 27 times 1/9, that's just going to be 3. Well, how do you get 1/3 to flip over to be a 3? That has to be a -1. That's how you get the exponent to flippy as you go back and forth. So again, setting those up as a singular log, convert it to an exponential, guys, and then that works out really well. All right, now, so if multiplying, you add the exponents. When you divide, you subtract the exponents. Okay, so those things kind of hold true here. So once again, if you're subtracting two logs with the same base, divide the first by the second, and we can write it as a singular log. Okay, so here we go. This one, so we have log base 5, and then we're just going to take 100 divided by 4, which is 25. All right, 5 squared is what's equal to 25, and then we solve the problem. Kind of nice, those logarithms, kind of slick. I like it. Yeah, pretty slick. All right, so this one, let's do this. Log base 7. All right, so we're going to take 49 divided by 7, which of course is 7. Well, 7 to the first power is what's equal to 7, and there we go. And if you ever get confused, like I said, don't be afraid to use that log base if you're not really sure. All right, so here's another one. This one is kind of a really good property here. When you have a log with an exponent, you can bring that exponent out front. Okay, so right here is what we're looking at. That's going to be a really key one in solving as we move forward here. So let's take a look at a problem or two that has that. All right, so log base 2 of 32 to the 6th power. So once again, by using our exponent, we can put that 6 out in front and just say 6 times log base 2 of 32. Well, this becomes quite a bit easier because 2 to the 5th power equals 32, so that just equals 5. So our answer is 30. All right, now again, could you type that into the log base on the calculator and do it? Sure you could, but a little more fun to understand those properties. Let's try in a couple others with these that we have here. All right, so log, remember, whenever it's log without a base, we assume it's 10. We're going to put a 4 out in front. So 4 times the log of 10. So 10 to what power equals 10? Well, that's 1, so our answer here is just simply 4. All right, here, let's put the 2 out in front. 2 times the log base 5 of 25. Well, 5 to the 2nd power equals 25, so that's just 2. 2 times 2 is 4. Crazy kooky, but it's true. All right, some other properties that we have here looking ahead is that if we have log base b of b to the x, well, the answer is just x. You also look at, too, if you have a base of an exponent b raised to the log of the same base, it just eliminates each other. You're just left with x. All right, so as we kind of look at some of these problems here, all right, so we know here if we have 3 to what power equals 3 to the 11th, well, that's just 11. Those cancel each other out. This one we know 3 to the 4th power would be 81. We know that one. Here, the 5 and the log 5 cancel each other out, and we're just left with 10. All right, so again, some of those properties that we have here. Now, this is a sneaky one here because remember, it is base 10. So 10 to what power equals 10 to the 0.9? Well, that's just 0.9. Here, the 2 and the log 2 cancel each other out, and you're just left with 8x as your answer. Okay, using those properties that we have. Again, have those properties handy as we take a look at those. All right, now another thing that you can do is since most calculators calculate logarithms only in base 10, now the calculator we do have that log base. Another way of doing this is to actually do what's called a change of base formula. So if you have log base 4 of 8, another way, you could always put it in the log base, that's fine. And again, I would not, you could change to whatever base you want to. So it makes sense to always change it to log base 10 to the common log. So I wouldn't do it this way. All right, what I would do is I would just write this as the log of 8 divided by the log of 4. Sorry about my penmanship there. So do it that way. And again, we'll show you a couple problems what we're talking about here, how we get the same thing. It's really kind of neat. All right. So again, changing the base. If you had log of base 32 of 8, we're asking 32 to what power equals 8? So we know it's going to be a fraction. So instead, what you could do is you could take the log of 8 divided by the log of 32, and you get your answer. Now, let's go back to our friend the calculator over here, and let's go to our log base. And let's put that in there. So let's see if we had 32, and we went to 8. I'm sorry, I did that wrong, didn't I? Log of, 32, this is 8. All right, we put that in. Look at that. You do get 0.6. So the formula does actually work. It's kind of crazy kooky, but it's true. It does work. So let's try another one. 9 to what power equals 27? Well, we know 9 to the first power is 9. 9 squared is 81, so we know it's got to be a 1 point something. So what you could do is the change of base. Just take the log of 27 divided by the log of 9, and you get that. Or, like we said, we could always go over here to our log base. Some of the older calculators don't have this. The app we have on the Chromebook certainly is fine. It does have it, but if you don't, you always have that as an option. So we'll do log base 9 of 27. We type that in, look at that, you get the same thing either way. All right, so again, nice tools to use calculator-wise. Get to know these properties, some experience with those. Have those notes handy. Put a few examples down on your notes, and should be all good to go.